Okay, sometimes our factoring trick doesn't really work. There's really not much I can do right here to say, well, where does sine of x minus cosine of x equal 1 on the interval from 0 to 2 pi? And so another trick that they like to show you in the book right here is one where, well, we can sometimes use some trigonometric expression like we did with the radical equation and square both sides. Like in this case, we have sine of x minus cosine of x equal to 1. So let's take both sides and square it and see what happens. Remembering that anytime we do an arithmetic operation to one side, we do exactly the same operation to the other side, and we can find a set of solutions that may work. So what happens? Well, on the right-hand side, of course, it's equal to 1. 1 squared is itself. But what about sine of x minus cosine of x? Well, don't forget, that is actually a situation in which we would have to carry out the FOIL method if we were to carry this out, or if you happen to remember your special form multiplications, you can actually carry out this multiplication a lot faster, right? Anything squared means multiplying it by itself, so there's going to be multiple terms right here. And the multiple terms will go like this. We're going to get the square of the sine of x. We'll be subtracting 2 times the product of sine of x times cosine of x. And then we'll have added to that the cosine of x. And all that's equal to cosine squared x. Now, all of that is equal to 1, and so we say, well, that still looks like an awful looking thing, except for the fact that we now have sine of x plus cosine squared x. And we know that by our Pythagorean identity, that's equal to 1. And so on the left-hand side, we actually have the equation now, 1 minus 2 times the sine of x times the cosine of x equal to 1. Well, let's see if we can get this into any form. If we want to set it equal to 0, we would subtract 1 from both sides, perhaps to get this into a form that we can deal with. But if we do that, we get negative 2 times the sine of x times the cosine of x equal to 0. And dividing by negative 2 just gives us sine of x times cosine of x equal to 0. And this is actually easier to handle because whatever angle x we're looking at, it's going to be the kind of angle that when we take the product of the sine of that angle or the cosine of that angle, we're going to get 0. So in fact, we've got two solutions to solve. Either we're going to find where sine of x is equal to 0, or we're going to find where cosine of x is equal to 0. And we only find sine and cosine of x equal to 0 at quadrantial angle positions. For example, we know that if we were to take the inverse sine of 0, we would get 0. But since sine is the kind of angle that's positive or possibly negative as compared to any other angle in the third or second quadrant, we could take x equals pi plus or minus 0, either one, and find that x equals pi is our other possible solution right here. Then we're going to look at cosine of x. Where is it equal to 0? Well, cosine of x is the kind of function that if we were to take the inverse cosine of 0, we would find that x is equal to pi over 2, because pi over 2 is in the interval from 0 to pi, which is the angles for inverse cosine. But that's a quadrantial angle along the vertical y-axis, so we go to the other y-axis down low, and we get x equals 3 pi over 2 as the other position at which cosine is equal to 0. And so we go back, and we should actually check to see do all of these work. So we want to make sure that we do check. And this is the kind of equation, remember, because we did an operation on both sides, like squaring, we have to make sure that all of them work. So let's try it out. What happens at 0? Well, if we take the sine of 0 and subtract the cosine of 0, we should get 1 if this equation is true. But the sine of 0 is 0, and the cosine of 0 is 1, and 0 minus 1 is not equal to 1. So x equals 0 is not one of our solutions, right? This is why it's important to check if you do a trick like squaring both sides. What about our angle pi? Well, at x equals pi, if we take the sine of pi and we subtract from that the cosine of the angle pi, if it's correct, we should get 1. The sine of pi is 0. The cosine of pi is negative 1. And of course, 0 minus negative 1 is equal to 1, and so that works. And so x equals pi is a solution. That's good to go. Just checking some of our others right here. Let's see what happens at x equals pi over 2. If we take sine of pi over 2 minus the cosine of pi over 2, we should get 1 if the equation is true. Of course, we get 1 minus 0 is equal to 1. That's true. So x equals pi over 2 is a solution. How about 3 pi over 2? Well, kind of like in the first solution, we've got sort of a problem here because the sine of 3 pi over 2 is not going to be positive 1, even though the cosine of 3 pi over 2 is still 0. And the reason is that sine of 3 pi over 2 is negative 1. It's a quadrantial angle on the negative y-axis. Minus 0 equals 1. Well, of course, negative 1 does not equal positive 1, so this is not a solution. So our solution set is only going to be the values x equals pi over 2 and x equals pi. So do make sure that if you do some trick like this where you square both sides, this is where you make sure that you check your solution. Okay, more to come.